All right, here we go. Today what we're doing is chapter 2.8, which is regression. But now we're doing quadratic regression instead of linear regression, okay? So if we're doing quadratic regression instead of linear regression, you need to understand the difference between them and why you would choose one over the other. Just like with mx plus b linear regression, there was an r value, yes? When we did linear regression, we looked at the r value, and the closer the r value was to 1, the closer it hit all the points, the more accurate that data was, which means that would be the equation that you would use to do future predictions, correct? Well, we're going to do exactly the same thing when we're going to do it with quadratic regression rather than just linear. And we're going to compare and contrast the two models to determine which one is better. So on page, I think, what page did I say, 165 maybe? On page 165, number 13, the directions say the table shows the percent P of public schools in the United States with access to the internet from 1994 to 2000. Use a graphing utility to create a scatter plot of the data. Let T represent 4 corresponding to 1994. So what are you immediately going to put 1994 as? 4. So this is going to be 4, which means 1995 is going to be, keep going. Okay, now, just like we did before, we're going to do lists and spreadsheets, right? So I want you to pull up your graphing calculator. And you are going to land on cell A and on lists and spreadsheets, and what are you going to label that? Go home, hit your house, and then new document. No, you don't want to save the unsaved document, and you want a list and spreadsheets page. Yes? Are we good? Okay, so what do we label cell A? Year. Hit enter. Click on cell B, and what are we going to label that as? Right? Percent. So we're just going to label that as percent. Now, I want you to click on cell 1, row 1, column A. And that's where you're going to start entering your data. The data that you're entering is 4 through what? 10. So 4, 5, 6, 7, 8, 9, 10. How do I get to the top of my data? Control 7 takes you to the top of your data, right? Okay, go over to row 1, column B, and now you are going to enter in this data. So 35, 35, 50, 65, 78, 89, 95, and 98. Yeah. This is also in your textbook on page 165. I'm guessing you didn't bring your book. Are we ready? Are we good? Okay, so now that we have our data, we've entered it. We are going to, I'm going to go where you guys are at, which is at the bottom. Now we're going to control doc, and we're going to add a graphs page because we want to actually physically graph this thing. So notice it brings me to F1. F1 means a function. I don't want to graph a function. What do I want to graph? A scatter plot. So you're going to hit Menu, Graph Entry, and what do you want? Scatter plot. And this is going to be year, Y-E-A-R, bless you. It bolds, arrow down. Then we're going to have this as being percent, P-E-R-C-E-N-T. And hit enter. Why can I not see it? The graph window is too small, so how do I get my scatter plot in its complete view? Menu, window zoom, and then 9 for zoom data. Do we see all of our data there? Now, it looks what? It looks like it's linear. Would you agree? Okay? But what I want you to draw the attention to is I want you to look right up and through here. Do you see at probably the third point all the way up, there's a little bit of a curvature to that? Okay? That little bit of a curvature is going to make the difference in the accuracy and the R values for future predictions. Do we all understand that? So what we're going to do is we're going to go through the steps to find our linear model first. So we're going to go ahead and do Control Doc, and we're going to add a linear model. We're going to add a calculator page because we're going to do some calculations. And we're going to hit Menu. What do I want next? Statistics. Then what? Stat calculations. Number 3, which is MX plus B. X list is always going to be your X, which is your year. Y list is going to be your P, which is going to be your percent. We're storing it into F1. Okay? Now, you are just going to write this down and compare and contrast. So your equations are Y is equal to MX plus B. So Y is equal to the 10.8214X minus 2.89286. Then I have an R value here. What is your R value? 0.9782. Do we all understand that? Are we good? So my linear model okay, does that look like it's pretty close to you? Is that R value pretty good? Yes, so we're going to go back and we're going to graph this on 1.2 because I want to see how many of my points it hits. So I'm going to go ahead and hit Menu and Graph Entry, and I want Function, and I'm going to arrow up to F1 and activate it. How many points does it actually hit? 2 points. Is that very accurate? You have to arrow up to F1 to activate it. Okay. All right. Do we all understand that since it only hits 2 points, is this the very best that you could get? Probably not. You could probably do a lot better on this one. Do we agree? Okay, so let's go ahead and see if we do the next model, which would be quadratic, see how that goes. So we're going to go back to 1.3, which is our calculator page, and now we're going to do a quadratic model. Okay? So we're going to do the same steps that we did for the linear, so Menu, Statistics, and Stat Calculations, except for this time, which one am I going to choose? Number 6, which is Quadratic Regression. In my X list, I'm going to still choose as my year. My Y list, I'm still going to choose as my percent, but this time I'm going to store it in F2 because in F1 is my linear model, and F2 is going to be my quadratic model. And I'm going to press Enter. So I'm going to go ahead and write down my equation. My equation for this is going to be Y is equal to AX squared plus BX plus C because that's the equation of a quadratic formula or a quadratic model. A is going to be negative 1.29762x squared plus 28.9881x minus 61.2857. Yes? Now, my R value is not given here. What they give me instead is an R squared value. So you actually have to calculate your R value. So I want you to legitimately hit the Control X squared key, 0.998096, and hit Enter. And that tells you that your R value is 0.9990 because that's a 4, and that is not going to be rounded up. Do we all understand that? Do we all get that? Okay? Now, according to R values, which model is better? And I'm going to go over to here on my other page, and I'm going to write that down. So Everybody knows what I'm talking about. Plus 28.9881x minus 61 point. And then my R value is the square root of that, so it's 0.9990. Okay, now, according to R value, the quadratic formula wins out over the linear model. Do we all understand that, yay or nay? Why does it win out? Because which R value is closer to 1? The quadratic model is closer to 1. So now let's graph it. If we graph these, the quadratic model, we're going to see how many points our quadratic model hits. So let's go to 1.2. Some of you are zoning out on me today. I want you to go ahead and hit menu, graph entry, hit function, arrow up to F2, and activate it. How many points is this one hitting? Almost all of them. See how you thought it looked very linear before? But then whenever you see the other model up against it, you're like, man, I can't believe how I thought it looked like it was 100% going to be mx plus b, but it's not. It's actually quadratic ax squared plus bx plus c. Do we understand the difference? Now, if I go ahead and do predictions on this model, understanding that in the year, 4 represents 1994 and 10 represents 2000, when will I have 100% of my schools having internet? If I hit Control T, I'm not going to look at F1 because what is F1? F1 is my linear model, bless you. So I need my F2, which is going to be my quadratic model. So I'm going to scroll down here, and I'm going to look to see at when I'm going to have 100%. 100% corresponds to 11. And what year is 11? What year is 11? 2001. Do we understand that? Because 10 corresponds to the 2000, so 11 is going to correspond to 2001, and that is when I was going to have 100% of my schools having internet access. Do we all understand that? Now, what I want you to get is with a quadratic model, notice it's starting to go down. So after it hits 11, it starts to go down with the number of students or schools having internet access. Why? Why is it going back down? What's the shape of a quadratic? It's a parabola. It's symmetrical. So it has a maximum or a minimum value, and then the sides are going to be symmetrical. So it's going to evenly go up or evenly come back down. Do we all understand that? So in a situation like this, you know that you're going to max out at 100%, right? So that's why you would want to use the quadratic formula, because of the way this actually works. Future predictions past 100% is not going to work, because if we're asking the question of how many percent of my students or schools in Ohio have internet access, it's either 0% up to 100%. You can't have 110%, can you? Do we all understand that? So think about your problem and your scenario and be able to understand that. Tonight's homework is ridiculously easy. You have 2 regression models. That is it. You have the rest of the period to get this done in class today so that you do not have any additional homework. Liz, that's Algebra 2 work, dearest. It was probably on the desk. Okay, now, problem 1. 1A, complete a scatter plot on your calculator of the above information, letting t equaling 5 for the year. You don't have to write anything down for letter A. Letter B, use the regression feature of a graph utility to find a quadratic model. I expect to see exactly what I did. So on letter A, or I should say letter B, I want to see this part right here. I only want to see the quadratic model, okay? Letter C, graph your regression model with your scatter plot. Is the quadratic model a good fit for the data? Put yes or no and tell me why. Because it's hitting all the points, or it's hitting 5 out of the 7 points, or it's hitting 2 points, so no, it's not. And my R value is this. So therefore, it's closer to 1 or it's not. Do we all understand what I want there? Letter D, what is the prediction for the number of hours a person will play video games in 2001? There should be a number there. And letter E, what is the prediction for the number of hours a person will play video games in 2005? Again, a number. Turn it over, the same scenario for the other side. Any questions on what I'm wanting you to do tonight for homework? Are we solid? Okay, the rest of the period is yours. You should be able to get this done in class today. Once you do get it done, go ahead and place your homework into the bin, and I will grade it. If you have last night's homework was 2-7, the asymptotes, the slant asymptote worksheet. Staple your graphs to it and put it into the tray for me to grade. If you have your 2-6 worksheet, including the 7 through 12 all, staple 7 through 12 all with the work attached to it. Don't just tell me you graphed it because it says without using a graphing utility. Yes, the matching. Go ahead and put that into the tray. Any questions? On this particular problem that we did in notes today, because it started with the year 1994. 1994 was whenever they first collected data, which is why t equals 4 is 1994. On tonight's homework number 1, you are going to start with t equaling 5 corresponding to 1995. Make sense? Okay. All right, the rest of the time is yours.